What we're going to do is we're going to look at dividing rationals. Now, dividing rationals, you've done in junior high, where you have 3/5 and we divide, let's say 1/5. And what happens is we multiply by the reciprocal. Some teachers say keep, change, flip, meaning we keep the first fraction, we change the division to multiplication, and then we flip the second one. And this is what it means by multiplying by the reciprocal. We see that the 5's cancel, and we end up with 3/1, or just 3. And so that's what we're going to do today. So with this right here, we're going to be simplifying and stating the excluded values. I picked a few problems that are already factored, so we're not going to spend our time with the factoring. What we're going to do is we're going to look at the dividing and stating the excluded values. So looking at letter A, we have division. So that means that we're going to multiply by the reciprocal. So we have our first term, which we're keeping the same. We're changing the division to multiplication. And then we're going to flip the second one. We're basically multiplying by the reciprocal. I'm going to multiply across, so that gives me x to the 6th and y to the 14th, x to the 7th, and y to the 4th. Remember, when we multiply, we add the exponents. Now I'm going to look at the dividing. So with that right there, 6 and 7, there's more x's on the bottom. 14 and 4, there's more y's on the top. There would be 10 more. Now, when we're looking at our excluded values, remember that when we're talking about monomials, it's always 0. So x cannot equal 0, but this time we also put y cannot equal 0, because that's not the only variable. Being x, there's also a y. So we have the excluded values for x, and we have the excluded values for y. Now for the next one, once again, we're going to keep, change, flip. We're keeping the first fraction the same. We're changing the division to multiplication. And what we're doing is we're multiplying by the reciprocal, which means we're flipping it. What we're going to do is we're going to cancel. X minus 7's cancel. We see that 3 and 5. 5 minus 3 is 2. There's also an x up here, so the 2 becomes a 1. And the 6 goes into 12 2 times. So what we end up with is 1 on top. And in the bottom, we have 2 to the x, 2 times x, and then x plus 7. Now that's the simplifying. When we're looking at our excluded values, what we're doing is we're looking to see what gives us 0 in the denominator. Now, division is much more difficult than multiplication. We have our monomial, which is 0. We have the 7 and the negative 7, which is right here. But remember that we had a denominator right here that we also have to look at. Now, thankfully, this is also 0, so we don't have to add anything. So that right there is our excluded value. Now, looking at the next one. First thing that we're going to do is we're going to keep, change, flip. We're keeping the first fraction the same. We're changing it to multiplication. And then the second fraction we are flipping. Then what we're going to do is we're going to cancel. So 2/4 reduces to 1/2. X plus 8's cancel. X plus 5's cancel. 16 and 6 both have a 2 in common, so that becomes 3/8. And the minus 9's don't cancel. They're both in the denominator. So what we have is 3x minus 1. Then we have x plus 1. We have an 8 and an x minus 9. And then since there's two of them, what I can do is I could put x minus 9 twice, or I could put x minus 9 squared. Either way is fine. That right there is my answer. When I'm looking at my excluded values, x cannot equal. This right here is a negative 8. This right here is a 9. Then I have another 9. I'm not going to write it twice. And then I have a negative 5. Now remember, these right here were once in the denominator. So I also have to put those. Here I have a negative 5, which I already have. Here's a negative 1. I don't have that, so I'm going to put the negative 1. Okay, what you're going to do is you're just going to pause it for a second and try the next problems. Okay, looking at the next ones, we're going to keep change flip. We have x to the 7th, y. We have x to the 5th, y to the 3rd, times x to the 3rd, y to the 5th, and we have x squared, y to the 6th. Now, whenever we multiply, we add the exponents. So that right there becomes x to the 10th, y to the 6th. Then we have x to the 7th, y to the 9th. We're going to see if there's more x's on top or on the bottom. And we see that there's 3 more on the top. We see that there are 3 more y's in the denominator. Now, the next thing that we're going to do is we're going to state the excluded values. Since it's a monomial, monomials are really nice. So x cannot equal 0 and y cannot equal 0. If we're looking at the next one, keep change flip, we have the x plus 5, we have the 21 x to the 4th times 14x squared, x minus 3, and x plus 5. We see that the x plus 5s cancel. We see 14 and 21 both have a 7 in common, so that would be 2/3. And then 2x's and 4x's, they cancel, and that becomes 2x's. So we have a 2 in the numerator. We have a 3x squared in the denominator, and then we have an x minus 3. For the excluded value, x cannot equal 0 because that's a monomial. And then we have 3 and negative 5. The monomial here is the same 0, so we don't have to put it twice. Now, if we're looking at the next one, what we're going to do is we're going to keep change flip just like the other one. And when we keep change flip, we're going to keep the first fraction the same. We're going to change the division to multiplication. And then what we're going to do is we're going to cancel. So we have the x minus 5s. We have the, 2 and the 12 become 1 and 6. Then when we're looking, notice negative 6, positive 6, we can't cancel those. 9 and the 15, they both have a 3 in common, so that would be a 3 and a 5. And 3, 6 becomes 1 and 2. And so when we're looking at this, what we have is the x plus 4, and there's 2 of them, so it's squared. And then we have the x plus 6. In the denominator, we have 2x plus 3s, so x plus 3 squared. and then we have an x minus 6. And then what we have is our 2, which is in the denominator. Now, the next thing that we're going to do is our excluded values. And when we're looking at our excluded values, we're trying to see what gives us 0 in the denominator. So we have the -3 is the first one. We have the 6, which is the second one. What we have is the 5, and then the -3, which we already have. But remember, this was in the denominator before, so we also have to include those. So that would be a -4 and a +5, which we already have. So no need to put it again.